All right, guys, in my last video, we calculated the velocity of a satellite in an orbit. Okay, remember I told you that a satellite, for a satellite to keep revolving around the Earth, it must have a significant velocity, okay, that will help it to be in that orbit. Without that velocity, it will fall inside the Earth. So you know that velocity can also be given as V equal to what? 2 pi r all over what? T. This capital letter T is the period, okay? This r is the radius of the orbit. Now, let's know, this is Earth, planet Earth. This is Earth. Now, this is the surface of the Earth. Now, this is the orbit we are talking about. Let's say this orbit. Now, the radius of the orbit will start from the center of the Earth to the what? To the circumference of the what? Of the orbit. So this is our r. Okay? So you can use this equation for the velocity of the satellite in the orbit. Okay? So that is it. So now let us take care of what we call weightlessness. That is weightlessness. You know, all these astronauts, like when they are in space, they feel weightless, like having no weight. Do you understand? So this is what we want to discuss today. Now, remember, I told you that weight, yes, weight is as a result of the force of attraction the Earth has on an object. Do you understand? But what makes you to feel that weight is what? The upward force exerted by any body that your feet is touching. Do you understand? Like, take for instance now, you feel weight in an airplane, that is in an aeroplane. Yes, you can walk on the inside the aeroplane. You can walk. Do you understand? You feel weight, but the weight you feel there is not exactly the same weight you feel on the ground. Why? Because you are in another orbit entirely. Yes, you are in another orbit. Now, the floor of the airplane is providing what? An upward force on you due to the gravitational attraction of the Earth at that what? Orbit. Do you understand? Do you see the sensation of weight now? So now, see what you will understand here. Now, we have that this is let's say W is as a result of the force of attraction the Earth has on you, and it is downwards. Do you understand? So mg is your weight. Do you understand? W minus mg is equal to what? Is equal to 0. Okay, that is if you are on something that is motionless. Do you understand? You are as you are standing on the surface of the Earth, or let's use an elevator in this case. When an elevator is not moving, this equation is what? Satisfied. Do you understand? Now, but when the elevator is moving, you are in an elevator, okay, and you are standing on the elevator, and it is moving upwards. Now, if it is moving upwards, the acceleration is upwards. So this net force now, W minus mg, will be equals to what? Will be equals to mass times acceleration, ma. That's your mass times acceleration. So the W is equal to what? Ma plus what? Mg. We call this W your apparent weight. Do you understand? The apparent weight. Okay. So this sum, it is what you will feel. Do you understand? So you will feel like the reaction will be much, like you will feel that you are heavy as the elevation is what? Moving up. Okay? So now, if the elevator is moving down, the elevator now is moving down. Now, see what happens. Now, if it is moving down, the acceleration is now negative. So the apparent weight will be W equals to what? The acceleration is negative. That is minus ma plus what? Mg. Okay, you know, gravity is acting positively downwards. Okay, so now W is equal to mg minus ma. So as the elevator is moving downwards, you see yourself, your weight will be reducing. Do you understand? It will be reducing. Let's say in the first case, the acceleration, you are moving with half g, that is, or g over 2, that is half g, okay, which is g over 2, in the first case. So in this first case, that means your weight will be equals to m times g over 2 minus mg. So when you do this, that is m is equal to mg over 2 minus mg. Mg over, sorry, plus in this case, sorry, in this first case, plus. So plus, so we now have W is equals to, that is mg plus mg over 2. You know, it will give us what? Mg plus 2 mg, which will give us equal to what? 3 mg over 2. Do you understand? We have 3 mg over 2. Do you see? So when you are going up, you see your weight, that is, it will be 3 over 2 times your weight. Do you understand? 3 over 2 times your weight. Now, when you are going down, let's say with the same acceleration, g over 2, you are going down with the same acceleration. So your weight will be equals to mg minus, this is mg over 2. So equal to what? Equal to, that is 2 mg minus what? Mg. Okay? So which will give us what? Mg over what? 2. Do you see? So it will be half your weight. That is, as you are going down with this acceleration, you will feel half your weight. Do you see what is happening now? So now, what about the case whereby the acceleration is equal to g? That is, in that sense, that is the things that are holding the mechanism that holds the acceleration to its, the elevator to its walls. It has been neutralized. That is no more, such that the elevator is now falling down. Okay? In that condition, there will be no reaction on you. You will feel weightless. So in that sense, using this equation, this one now, using this one, we have that W, your apparent weight, will be equals to what? Mg minus what? Mg. So your apparent weight is equal to what? 0, because you are falling. Do you understand? This is what astronauts in the outside orbit, this is what they feel. They feel weightless. Do you know? Because they are falling. That satellite you see, it is what? It is falling. Why it is rotating around the Earth is because the Earth's gravity is what is attracting it. So it forms either circular part or elliptical part. But it is a falling object. Do you understand? Just like if I throw this marker now, the marker will form this part. You know, this marker is a projectile. So it will form this part. You know, I threw it forward. So it will, you see what happens? The marker will go like this. You see? That is exactly what is happening. The marker, this marker now is falling. Do you understand? But because of the Earth's gravity will be attracting it such that the part will be either elliptical part or circular part. Do you understand? But in this case, is a parabolic part. Do you understand? So this is what actually happens. So this is weightlessness. Do you understand? This, you know, in my other video, you can actually you know what I say something in that video. I say if the Earth is rotating fast, like very, very fast, you will also feel weightlessness. That is, if the centripetal acceleration is g, you can also feel weightless on the surface of the Earth. This one, as we are standing on the surface of the Earth. Okay, so this is it. So in my next video, we talk about escape velocity in my next video.